Today we're going to work on solving rational equations. And to do this, we're going to bring in some of the skills that you learned last week when we were adding or subtracting a rational expression, where you worked on finding a common denominator for two rational expressions, fractions, and use that to add or subtract. Because it turns out that there is still quite a bit more that we can do with rationals, even though you feel like we've spent quite a lot of time on it. So taking a look back, if you had an exercise, something like this, think about what you would do to solve it. And thinking back to middle school or algebra 1, you'd recognize that as a proportion, two fractions that equal to one another. And it's possible for us to have a proportion that is made up of rational expressions as well. So let's remind ourselves first of some vocabulary. Rational expression, in this case, rational equation, any equation that contains at least one fraction that has a variable in it. Right? Our lowest common denominator in class, we've talked about the expression that contains all the factors from the denominators of all the fractions without any duplicates. Another way to think about that is the smallest set of factors that represent all the factors from each denominator. And in a proportion, one fraction is equal to exactly one other fraction. So not all of these rational equations will be able to solve as proportions, but some we can. And you recall that when we have a proportion, in math terms, the product of the means is equal to the product of the extremes. Your math teacher may have said cross multiply. So cross products are equal. So A times B equals B times C. So let's look at the steps that we're going to follow. We're going to make sure that we have every denominator written out. We're going to identify the common denominator by finding the expression that contains all the terms from each fraction without duplicating any. And then we're going to multiply each term by that common denominator. The result is we're going to be able to divide out, or we don't say cancel, we're going to be able to divide out common factors in the numerator and denominator. So once that happens, we'll be left with an equation that has no fractions. So similarly to multi-step equations in algebra 1, when we multiplied by a common denominator that eliminated the fractions, and we had a more reasonable type of equation that you're used to solving, we're going to get the exact same thing here. And we'll solve for the variable, and then we double check just to make sure that we don't have any values that create 0 in the denominator. So thinking about solving proportions, x over 5 equals x plus 3 over 8. And we recognize this as one fraction equal another fraction, so we know that our cross products are equal. So we can say that 5 times the quantity, x plus 3, is equal to x times 8. So let's simplify by using the distributive property. 5x plus 15 equals 8x. And so this is the type of equation that you learned how to solve in middle school. So let's go ahead and do that. We recognize you have variables on both sides. We're going to subtract 5x. 5x minus 5x equals 0. So on the left-hand side, I have just 15. 8x minus 5x, that's 3x. So my solution is x equals 5. And when we looked at the original equation, there were no variables in the denominator. So there's no value of our variable that's going to create 0 in the denominator. And so there's no excluded terms here. Go ahead and pause the video and give this one a try. It's still a proportion, even though it looks a little uglier. 4 over 3x plus 3 equals 12 over x squared minus 1. I'll go ahead and get you started. In a proportion, your cross products are equal. So let's check your work. So if you multiply the cross products and simplified, you recognize maybe that you have an x squared term, which means that this is a quadratic. And so we're going to follow our procedures for solving a quadratic equation. We want one side of the equation to be equal to 0. And I also recognize that I have a common denominator of 4. So I'm going to divide out the 4. Left with x squared minus 9x minus 10 equals 0. So don't lose your common factor of 4, but we recognize that this is factorable. Two numbers that multiply together to make 10, and when I subtract them, I get negative 9. That's x minus 10 x plus 1. So now 3 factors all equal to 0. So 4 equals 0, or x minus 10 equals 0, or x plus 1 equals 0. Well, 4 equals 0 is nonsense, so we're going to ignore it. But we can solve these two equations, and I get x equals 10, or x equals negative 1. Double checking. What happens when I put 10 in for my x value? 3 times 10 is 30, plus 3, that's not equal to 0. 10 squared is 100 minus 1, that's not equal to 0. So that one's okay, but when I put negative 1 in here, 3 times negative 1 plus 3, is that equal to 0? So negative 3 plus 3 equals 0. That's a problem. Here, x squared minus 1 equals 0. So negative 1 squared minus 1, that's 1 minus 1, that equals 0. That's a problem as well. So that tells us that this solution is excluded, and the only viable solution to this equation is x minus 10. Moving on to the next page now. Thinking what you know about solving equations, what would you do to solve 3x over 2 plus 5 over 3 equals 15? And what we've done in the past is we recognize that we'd like to not have to solve equations that have variables in them, so we've gone ahead and multiplied through by a common denominator to eliminate the fractions. Let's take a look at what that would look like in an example problem. For instance, y over 5 plus y over 2 equals 7. So 5 and 2, I can see that I have a common denominator of 10. I'm going to multiply this entire equation by 10. So y over 5 times 10 gives me 10y over 5. Y over 2 times 10 gives me 10y over 2. And 7 times 10 is 70. Now I look for common factors. 10 divided by 5 is 2. This is 2y. 10y divided by 2, that's 5y, equals 70. 7y equals 70. If we divide both sides by 7, we can see that y is equal to 10, and there's no variables in the denominator, so this is a usable solution. We can do the same thing with fractions. I have x and 2 and a 2x. Well, this expression, 2x, already contains a factor of x and a factor of 2. If you notice that we ended up dividing out some common factors here, when we multiplied everything times the GCF, that's, or the lowest common factor, that's one possible way to think about it. Another possible way is to think about what do we need to multiply times x to get 2x, and multiply the top and bottom of this expression by that equation. So if I multiply 1 over x, top and bottom, times 2, I get 2 over 2x. Here, I have a 2 in the denominator. I'm missing an x, so I'm going to multiply the numerator and denominator both by x. X squared over 2x. And then x plus 4 over 2x. Well, now that everything is over 2x, I can just write 2 plus x squared equals x plus 4. And now again, I have a quadratic. Go ahead and pause the video, and you can take a look and check your answer. So again, in this particular situation, we ended up with a quadratic. And so you worked through, collected all your terms on one side, so that your quadratic was equal to 0. And then we could use the zero product property to factor and solve. And we ended up with x equals 2 or x equals negative 1. Going back to my denominators, x and 2x, the only way those are equal to 0 is if x equals 0. And that's not one of my solutions, so both of these are viable solutions. Let's take a look at one that's a little bit more challenging. X plus 5, 5 minus x. X squared minus 25 are our denominators. and you may feel a little bit like that looks familiar. You're not sure. There's something you feel like you can do here. And yes, we see x squared minus 25 is the difference of two squares. We know that factors is x plus 5 and x minus 5, but I don't have x minus 5. I have 5 minus x. But if I can rewrite this as negative x plus 5 and factor out a negative 1, I'll get what I need. So let's rewrite this. 3 over x plus 5 plus 2 over negative 1 times x minus 5 equals negative 4 over x squared minus 25. So I'm going to bring this negative 1 up to the numerator. So that'll be a negative 2. So I can write this as 3 minus 2. And it equals negative 4 over x squared minus 25. So I had x minus 5. To get to this common denominator, I need x minus 5. I had x minus 5. I need an x plus 5 in the numerator and denominator. And here this fraction stands because it was already in the common denominator. So 3x minus 15 minus 2x plus 10 equals negative 4. All of these are over x squared minus 25. So I'm able to divide out that common factor. So 3x minus 15 minus 2x minus 10 equals negative 4. So let's bring it back up here, combine some like terms. 3x minus 2x is 1x. Negative 15 and negative 10, negative 25 equals negative 4. So x equals 21. And in any case, does 21 give us 0 in the denominator? No. So that can stand as our answer. So what I'd like for you to do is to go ahead and work on 6 and 7 on your own. Go ahead and pause the video, come back and check the answers when you're done. Okay, so these two were definitely challenging. I get the sense that we might be taking a look at these at the outset of class on Monday. So let's check your work. In number 6, you had a case where there were 3 different expressions in the denominator. So our common denominator is going to contain one copy of each of these. 2 times 2x times x plus 3. And so we're thinking about, okay, I have 2x in this first fraction. What expressions are missing? Well, it needs a 2 and it needs an x plus 3. So I'll write those in the numerator. Here, I can see that I was missing a 2x and an x plus 3. And here, a 2 and a 2x. So if we go ahead and multiply those all out, we can drop through the denominators. Another way to think about that is we can think about dividing out those common factors right away. 1 over 2x. Let's save that for a little bit later on. Let's take a look at how we would work through this. So we multiply through and end up with a quadratic. 2x squared minus 8x plus 6 equals 0. Factor out the 2. We have with x minus 3 or x minus 1. And neither of those result in a 0 in the denominator. So these are both our answers. Good, x minus 3, x minus 1. Quickly, let's take a look at what would happen with number 7. This is a case where this fraction already contains a common denominator. C squared minus C minus 6 is the product of C plus 2 and C minus 3. So in this case, we can see that I need a C minus 3 factor here, a C minus 2 factor here. This one can stand. So this one also ends up as a quadratic, but a little bit easier to solve. We end up with the 3's being opposites and going to 0. So C squared minus 2C equals 0. We can still solve this using the 0 product property. Factor out a common factor of C. C times C minus 2 equals 0. So we end up with C equals 0 and C equals 2.